Alright, and welcome back. Last time I was with you guys, I gave you the definitions of the relative extrema, the relative max, the relative minimum, the absolute maximum, and the absolute minimum. But I didn't give you guys any examples, so today I wanted to double back and give you guys some examples of these things, just so we're more clear on understanding what is what. So keep in mind that a relative maximum is the highest point on the graph in its area. It has to be the highest on both sides of that point. And a relative minimum is the lowest point on the graph in its own little area, and it has to be the lowest point on both sides of it. I like to think of these as the peaks and valleys. Another term to think about these things are what's called the turning points. Turning points. Because the graph literally turns to make that peak or the valley. So if the function's going up, it turns and goes back down to make a maximum. And then when it's going down and then turns to come back up, it creates, oh, but you can't see what I'm drawing. So if the graph was going up, it turns to start going down to make this maximum. And as the graph's going down, it turns again to make this minimum. So turning points, extrema, all sort of the same type of thing. And now those are relative maximums, not necessarily the highest or the lowest points on the graph. That's what absolute maximums and minimums are. They are the highest point on the graph, period. That's an absolute maximum. So no other portion of the graph is going to be at that height. An absolute minimum is going to be the lowest point on the graph, period. No other portion of the graph is going to be that low. So I'm going to draw us a graph, and then we'll talk about the points inside of it. So here we go. What are you doing? We're drawing a graph. So let's get the vertical y-axis in there. Let's get the horizontal x-axis in there. And now let's draw a nice purple graph through this so that we can start talking maxes and minimums. That'll work. So there we go. There's our graph. Looks a little, I don't know, looks a little blobbish. But so everywhere that graph turns creates a peak or a valley depending on what it was doing. And those points are our relative extreme points. Well, in fact, they're all of the points. So we get a point here, that's where it starts to turn. It's turning here, that's like the kind of the lowest in its section. There's another peak. The valley's kind of right in there. Another peak, another valley, and another peak. Now, what we have to keep in mind is we have to consider all of the graph. So when I look at this point right here, this is a low point. It is a minimum. So for sure, we know that it's a minimum. But now the question is it a relative minimum or an absolute minimum? And if you were only paying attention to the points that I made, you might think that this was an absolute minimum. But we need to keep in mind that the other sections of the graph over here all have points, and there's infinitely many points over here too. And there's points basically in between all of those places that I made a little darker. Those are all points on the graph, and those have to be kept in mind as well when we're talking about this. So when I look at this minimum point, if I were to draw a horizontal line through it, I touch more of the graph right here, and if I was to keep drawing it horizontally, I might miss that other point, but I would touch more of the graph over here. So this particular minimum isn't lower than the entire graph. It's just a low point for this section of the graph, which means that this is a relative minimum. This particular point right here is a relative minimum. So now I'm going to talk about this point right here. That is a high point on the graph. But even as far as the mins and maxes that I've already put on the graph, it is not the lowest there. There are plenty of other high points like this next point we're going to talk about that I just dotted in blue. And in fact, all these points in between right here, all these points are higher than this particular point that I'm talking about, this point right here. The ones I just circled are higher than that red point. So this maximum is only a relative maximum. I'm going to abbreviate rel max. Hopefully we understand it as relative maximum. So going on to that next point that I marked in blue, I probably should have lettered these. Oh well, this point right here is another high point. It's another peak. But looking to the right of it, these points over here are all higher than it. So this is not an absolute maximum. Once again, this is a relative maximum. A rel max, if you will. Another relative maximum. Going on to this next point, actually I'm going to switch colors because there's like a lot of blue and red at this point. This particular point is another low point. And again, it's not the lowest on the graph because if we look, there are plenty of lower points that we've already talked about. The relative max and relative min from before are lower. But then there's also these arms of the graph that are pointing downwards are much lower than this point. So this is going to be another relative minimum. Which now brings us to this next high point, which I'm going to put a little blue dot on. This high point appears to be at the very, very top of the graph. So I'm going to draw a horizontal line through it. And if you notice, this horizontal line is missing, kind of shaking while I'm doing this. It's missing all of the rest of the graph, which means this point is the highest point on the entire graph, which makes it an absolute maximum. Right here, that is the absolute maximum because it is the highest point on the entire graph with no exception. That horizontal line touches no other part of the graph, so it has to be an absolute maximum because nothing ever reaches that same height to cross that horizontal line again. I'm going to move on to the next point. Again, this point right here, it's a low point. It's in the valley of that graph. And so this is a relative minimum. Once again, because there's other portions of the graph that are lower than it. And now the very last extreme point that I have, this one right here, it's a high point again. And I've already talked about the absolute maximum, and this point doesn't reach that same height, so it has to be a relative maximum again. Since it doesn't reach the same height as my absolute maximum, to match it and also be an absolute max, but it's still a high point in its respective area, especially if you just look at that little window around it. It is the top of that little mountain in the little window, so it is a relative maximum. I hope that this 10-minute video helps you better understand relative mins and maxes, and also helps you distinguish what is a relative and what is an absolute min or max. Remember to draw those horizontal lines through the entire graph if you think a point is an absolute, but if that horizontal line touches the graph again, it's not an absolute min or max, it's just a relative min or max. In the case where the horizontal line never touches a point again, it's got to be an absolute min or max at that point. I hope this helps. Leave a comment in the section below if you've got a question or if you want to see me make a video about a certain topic. See you next time. Bye.